Okay, so here's another example for related rates. We're going to talk about example 3. And you can follow in your textbook if you want, page 143. It says this: a spotlight is on the ground. Okay, so here's the spotlight, right here. It's on the ground. And it is shining on a wall that is 10 meters away. Okay, so this wall right here is 10 meters away. Frozen? Ah, sorry, thanks. A man 2 meters tall, so here's the 2 meters tall, this man right here, is walking away from the spotlight toward the wall at a certain speed, 1.2 meters per second. So this is his speed as he moves here. How fast is the shadow on the wall decreasing when he is 3 meters from the wall? So this is a related rates question. Here's one rate, the speed of the man as he moves. Here's the other rate, how fast is the shadow decreasing? And that's this one right here. See, this would be the man's shadow, right? Here he is walking. Oh, now I've started drawing this. Gonna have to finish there now. All right, this is him walking here. Right? I know, it's amazing. Okay, so that's his shadow. As he moves closer, because this man doesn't change height, right? Okay, now I'm just going to stick man. Okay, he's moving here. As he moves closer, guess what? His shadow is going to be smaller, right? So just make sure you understand the question makes sense, and we're looking for the change in y over time, right? Change in y with respect to time. So let's write some things down here. Well, the diagram is given to you, so what you're going to have to do is you're going to have to split this diagram up a little bit. You're going to have to put some more information on. So what we're going to have here is we're going to have this distance that the man is away from the spotlight as x. Now, why do we want to make that x? Because we are given the rate of change of the man's movement. Now, that would be distance per time. So you need to have a distance from somewhere, right? It's a positive rate of change. So he is moving in a positive direction or away from what would be a start point. So if this is not given to you in the diagram, you're going to have to label this distance as x, because x prime, and I'll write it up here, x prime, his rate of change, from like his positional change over time, is 1.2 meters per second. And it's a positive, right? So he's moving away from some kind of start point. So his position is changing at this rate. So we need to know what his position is, and that's going to be x. Okay? So that's, I mean, if that's not given to you in the question, you might be going, what does that mean? Now this will come later. The 10 minus x will come later. Of course, we have a total distance of 10. And so 10 minus x would be this remaining distance. So if and when we need that, we'll talk about that later. And so if you're not given this as a variable here, okay, this would be the shadow length. Obviously, we're looking for the rate of change of the shadow. So whatever that variable is going to be, we don't know the rate of change. We know it's going to be negative. Should be negative if we're doing things correctly. And then, of course, the third part of it is when he is 3 meters from the wall. Oh, okay, so that makes sense now. So this, we're trying to find x prime when this is 3. Excuse me. Okay, so when this is 3. When that's 3, what is x going to be? Yeah, so it's at x equals 7. So to tell you the truth, I don't know if you need to have this at the beginning, but they're just saying that because this is 3, you're going to have to realize that you're going to have to write this in terms of x, because you can't have another variable, and you have to know where to put it. And so this 3 is going to have to be written in terms of x, which is going to be 10 minus x, right? 10 minus 3 is going to be the x, or so, the leftover. Okay. So these are 3 pieces of information: the rate, the related rate, and the other information that gives us a point in time where we have to take this snapshot. Is everyone good with that first part so far? All right. So let's move on. Let's make a little bit more space here. So the step 2 that we talked about, where are those steps here? Okay, right here. Step 2 says take, I guess 1. Determine an equation that relates the 2 quantities. All right. So x and y. We have x and y. It's a right triangle here. So Pythagoras would be this squared plus this squared equals this squared. Well, we don't have any information about the length of the shadow. That's not given. So that would be the hypotenuse. So this Pythagoras probably isn't going to work. However, what you might notice is that throughout this question, we would have similar right triangles. Okay? So we have two triangles, and I could draw those separately over here, I guess. A small right triangle and a larger right triangle that's exact same shape. Just different size. So we have x and 2 here, right? And we have 10 and y here. See that? So this is this is what you need to capitalize on. This is how they're related. And how does that become an equation? Similar triangles have proportions that are identical to each other, right? So 2 is proportional to y, x is proportional to 10. You could write it different ways. You could write y over 10 would equal the same ratio as 2 over x would equal. Right? That would be probably simplest, I think the most straightforward. All right? And in this way now, again, y prime is one of the things we're looking for, so I think it would be a good idea to solve for y here. Y would be 20 over x. So I think that's probably a good thing to do, right? All right. So we have an equation that relates both of them. I don't think that you have to do much more than this, but you could do this. Y equals 20 times x to the negative 1. I would suggest doing that. So there's your equation that has both variables in it. This is not a derivative, that's to the negative 1. Because the second step says that once we have the equation relating the two variables, we need to take the derivative, right? So again, do not put x equals 7 here, okay? This is a grave mistake. Students have done this before. Okay, that's no problem. That's y equals 20 over 7. I'm going to take the derivative of both sides. Oh, great. Y prime equals 0. The answer is 0? No, it's not. So don't put this value in before you take the derivative of the whole equation. Okay? So very important to know that. And that happens, well, it happens every year. Okay? Students do that, and it's like, oh, and you laugh now, but like this is pretty easy, and I've mentioned it already several times this class. But when it gets a little tougher, it's like, oh, do I put this in now or not? But you have to take the derivative first, okay? All right. So y prime equals, let's do power rule, negative 20 x to the negative 2 times x prime. Okay, so again, we're taking the derivative, and I'm using Newton notation here, so I'm not doing Leibniz, but really it's dy with respect to t. And I got to take, dx with respect to t, right? Differentiate both sides. So that's really what we're doing. Okay, if that needs to be mentioned or not, I just don't like Leibniz notation a whole lot for some of these things. I think this is just a bit more straightforward for me anyways. Okay, so are we good now? What do we do now? Yes, now we plug x in. Now we plug x in, and now we plug x prime in, right, and now we solve for y prime. So this is awesome. Okay, so we have negative 20. Now this x, we said, was at the point where x is 7. Awesome. And then x prime we're given as 1.2. So obviously we're going to be dealing with some decimals here. No problem with that. So jump on your calculator there and see what that gives us. Y prime. I mean, you don't have to deal with decimals here, I guess, but you should have something like 24 over 49. Does that sound right? Or what? What's that in a decimal form? I do that. Your calculator, just throw me a decimal if you want. Oh, this is going to be negative, thank you. 0.489. Yeah, so just under half, right? Okay. All right, so that's y prime. Good. And that means that the rate of change, and again it's negative, so that's awesome, the rate of change of the shadow is decreasing at this rate. And what's the rate again? Let me see. Oh, we got to go back. I've got meters and meters. Okay, that's good. We should have checked that at the beginning. But it's meters and it's seconds is the time. So this is going to be changing 0.489 meters per second. Okay? And I'll just let you do that. You can write a finishing sentence there, therefore the shadow on the wall will be decreasing at a rate. Now, if you say decreasing, you don't really have to put the negative in there. But if you say the rate is changing and don't mention the word decreasing, you make sure you have your negative sign in there. Does that make sense? So you can say decreasing at negative. I'm fine with that. But there's your example. That's number 3. And this similar triangle business sometimes trips students up. So any questions?